All right, here's a little wrap up on Dorothy and Toto. Okay, hopefully you got the idea of this. All right, so from start to finish, who travels further? Justify your answer. So hopefully you have chosen and justified what you thought. And again, please don't watch these until you've actually done it, because then it's just going to be a big waste of time for everybody. Okay, and then here you can see Dorothy and Toto's arguments for both of them. Okay, so basically the two ideas that we're trying to get at, okay, is Dorothy goes further if we talk in terms of what we call displacement. Okay, and displacement is basically just a change in position. You don't have to write this yet. We're going to write it and the little definitions at the bottom. I just want to explain it. Okay, right? So like if I think of this like a ruler, oops, okay, Dorothy started here and ended here. Okay, so she went, say, like that far. Toto, however, started here and ended here. So Toto, according to this ruler, has not gone as far. Okay, so if you're thinking in that terms, Dorothy is the winner. Okay, but Toto actually had what we call a bigger distance, which is basically like steps on the ground. Okay, Toto covered more ground getting to his place. All right, so Toto had to go step, 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 step. Toto had to go through this whole entire thing, all right, to get to that position. So kind of in a way, Toto sort of went further. Okay, all right, so those are basically the two different definitions we're going to use: displacement and distance. All right, so let's fill out a couple of these things in the table. So time, let me make this tinier because it's a little bit small. Okay, so time is, how to even define time? I don't even know what to tell you. Basically, time, we like to say it's a clock reading. That would be like an instantaneous time. All right, but more often we're concerned with a time interval, which would be more like a delta t. Okay, and delta just means change in, if you're not familiar with that from math or from physics way back when. Okay, delta just means change, and it's always the final minus the initial. Okay. All right, so t, sometimes you might see delta t. Sometimes we just use t even when we mean time interval, but we really should be using delta, okay? And the units are usually going to be seconds. It could be minutes or hours, but the AP test is not real big on converting units, and honestly, neither am I. It's a waste of time. So we don't have that. There's no equation for time, okay? Position is like a location on a ruler, okay? It's like a location in space, and it could be an X, Y, or even X, Y, Z coordinate, okay? Or if it's a one-directional thing, it could just be like basically on a ruler. Okay, the symbol is usually going to be X, okay, but it could be Y or Z, depending on if we're talking in 2 or 3 dimensions. We don't use Z that much, but just in case. All right, and the units, we're usually going to use meters. You may see centimeters, but again, the AP test isn't super big on even giving you numbers in the first place, really, so we're not really going to concern ourselves with much of that. Okay, and that doesn't really have an equation either. That's just like a measurement. Okay, displacement is the change in position. Okay, and I should have said this, but you need to be writing this somewhere. Okay, either in your class kick or in your notes. Take a picture and put it in there so I can see you did it, or, you know, just you need to write it down somewhere. Okay, change in position, which is always going to be a final minus initial. And this is important for direction, okay? And we usually call this delta x, delta meaning change, or delta y, delta z. But again, not that often. Okay, that's still in meters, and it's going to be final minus initial. All right, remember we're using x naught for initial and not xi, although it's fine. Okay, distance is, sometimes we like to call it path length, okay, or steps on the ground. It doesn't have direction. It just is what it is, okay? Displacement does have direction. It's going to either be positive, negative, or at an angle of 30 degrees from the horizontal or something, okay? Symbol is going to be D, still meters. All right, and there's no real equation for that either. You would just sort of have to like count up how many steps or how many meters were covered like by the feet on the ground. All right, now average velocity is what we just got from our other equation. So according to the lab, we had this. Okay, so the way we sort of switch this around is you're going to move this x naught to the other side. So now we have this x final minus x naught becomes delta x. okay, equals average velocity times time. So average velocity is displacement over time. Okay, really it should be delta over delta, right? But again, I don't know why we usually don't put the delta with the t, but whatever. Okay, so your average velocity is going to be displacement over time. Okay, and this will have a direction, and it basically tells you how fast you're going, well, on average, right? Which you'll see a little bit more next week, okay? How fast on average. So it doesn't really tell you how fast you're going unless it's like a constant speed, which is all we're doing right now, okay? So that's going to be like that, average velocity, and then that's in meters per second. Kind of ugly. Okay, so for now, for this week, average velocity is the only kind of velocity there is. It's constant, it's average, it's the same. Okay, but that's going to change later. Okay, you also might want to write this one down, V naught plus VF over 2, simply an average of the two velocities, because this is going to come in handy a little bit later. Okay, you won't need that one now, though, I don't think. Okay, all right, because for now, right, average and final, it's all the same velocity. So that would just be like doubling it divided by 2. Okay. And then average speed is just going to be the distance divided by time. No direction. Tells you how fast, again, sort of on average, and it's always positive. Okay, and we'll just call that S, I guess, in meters per second, and then its speed is going to be distance over time. Okay, as we play with these a little more, you'll kind of see what the nuances are, but for now, just think of like miles per hour, distance over time, displacement over time, depending on what it's asking for, okay? And on the next page or a couple pages, you're going to have to calculate the differences between the speed and velocity, right? So like say I start at home and I go to school, and this is like 10 meters. That'd be Marina, haha. Okay, right? So say home to school, 10 meters, right? Say this is 0 and this way is positive, okay? My distance here from here would be 10 meters, and my displacement is also 10 meters, positive 10 meters. Okay, but if I start at home, I go to school, and then I go back home, I've actually covered 20 meters on the ground, so my distance would be 20, okay? But I started and ended in the same place, so my displacement would be 0. Okay, all right, so that was kind of fast. We'll see how it goes. On the next page or a couple pages, when you do the speed and velocity, if you're getting those wrong, then you need to talk to me to make sure you understand it. Okay, if not, you should just probably blow through those pretty quick. All right, there you go.